Have you ever tried listening to a math problem being read aloud? If you've ever struggled to follow a complex equation while someone reads it, you're not alone. Today, we're diving into a fascinating study that reveals why text-to-speech systems often stumble when tackling mathematical expressions, and what researchers are doing to fix it. Let's start with the basics. When we convert math text into audio, it's not just about reading words. Think of expressions like square root of a minus b, or the integral from 0 to infinity. These aren't straightforward sentences. They require pauses, pacing, and even subtle shifts in tone to make sense. But here's the problem. Most AI-powered TTS models don't handle this well. Researchers found that when TTS systems read math, they often mess up prosody, the rhythm, stress, and pauses in speech. For example, if a model says square root without a pause between square and root, it can sound like squared root, leading to confusion. This tiny misstep can turn minus a minus b square root 2 into minus a minus b2 square root 2 in transcription, messing up the meaning. The result? Lower scores on metrics like COSI, correctness of conversion, and TeXBLEU, which measure how well audio matches the original math. But it's not just about pauses. The study also found that TTS models don't adjust their speed for complex expressions. Imagine trying to follow a lecture where the speaker races through a calculus problem without slowing down. Listeners get fatigued, and comprehension plummets. In one example, there was no pause between integral from 0 to infinity, and the variables inside, critical cues that humans naturally use to parse math. Here's where things get tricky. Even if an AI-generated audio file passes automated tests like ASR, automatic speech recognition, it might still be hard for humans to understand. The researchers tested this by running TTS audio through an ASR model. While metrics like character error rate, CER, and BLEU scores looked good, human listeners struggled. The disconnect. Automated metrics don't capture how natural or clear the speech feels. So what's the solution? The study highlights that human experts excel at this. When recording math audio, they use phrases like whole divided by or add deliberate pauses between parts of an equation. These subtle choices make a huge difference in how well listeners understand the material. But current TTS models, they lack this nuance, especially for complex math like matrices or summations. Let's break down the study's methodology. Researchers tested 5 TTS models, Google, Amazon, Microsoft, and others, by feeding them LaTeX equations. Since TTS can't process LaTeX directly, they used AI models like GPT-4 to first translate the code into spoken language. Then the TTS systems turned that into audio. But the real test? Human listeners. They heard the audio and tried to transcribe it back into LaTeX. The results were revealing. In simpler categories like numerics, basic operations, and numbers, most models achieved over 97% accuracy. But in calculus or advanced algebra, things got tricky. Symbols like pi or nested fractions often confused the systems, leading to lower scores. Even the best models struggled with prosody, like mispronouncing sin 2x as sine 2x instead of sine of 2x. Here's the kicker. The choice of AI model, GPT-4 versus others, didn't significantly impact results. It's not about the AI's smarts. It's about how TTS systems handle the structure of math. Without proper pauses, emphasis, or pacing, even a simple equation can become a jumble. But the study's most striking finding: human listeners rated AI-generated audio far lower than human-read versions. In some cases, the AI's version was so off that listeners couldn't even tell what the equation was. This isn't just about getting the math right. It's about making the audio intuitive for someone who's listening, not reading. So what's next? The researchers argue that TTS for math needs a paradigm shift. Current systems prioritize speed and accuracy over clarity. The future might involve custom-trained models that prioritize prosody, or hybrid systems blending AI with human expertise. Imagine a TTS that not only reads equations but explains them, using pauses and emphasis to guide the listener. In the end, this study isn't just about improving AI, it's about making math accessible. For students, scientists, or anyone who relies on auditory learning, the stakes are high. If we can teach machines to speak math like a human teacher, we unlock new possibilities for education and communication. Next time you hear a robot read a math problem, ask yourself, is it just getting the symbols right, or is it making sense? Because in the end, math isn't just about answers, it's about communication. And that's a challenge even AI is still learning to master.